Alrighty, race fans, welcome to another edition of the Workbench. Well, it's a big day here at the shop. We've got some new tools in that I think a lot of you guys will like. Specifically, two new things. We have a pinion tool and we have a tire sizing gauge, full size. Look at that beauty right there. Black anodized, laser engraved. We'll talk about these here just directly. Alright, the first order of business, we'll talk about the pinion tool. So I was a little dissatisfied with a number of the tools on the market, so I decided to try to make something that's maybe a touch more intuitive to you guys. So first of all, it's a standard aluminum fork. There's nothing magic here about that, but what we have done here is we've had laser engraved a couple of different things to kind of help you out, because not every 7-tooth or 8-tooth pinion gear is designed exactly the same. So the top hole is a general 7-tooth pinion hole. The bottom hole, or the middle hole, excuse me, is an 8-tooth, and then this bottom one is optimized for the Viper Scale Racing 7-tooth gear. Alright, so then on the back side, because we've optimized these holes, these major holes for different things, these back holes tend to capture the nipple on the pinion. So in a way, and you'll see this here in a minute, this could actually be a two-sided tool. So the top hole is 063, the middle hole 062, and the bottom is 060. So we've got a couple of gears right here. The first over here, this is a Scale Auto 8-tooth, and this is our Super Tough 8-tooth gear here. So picking that thing up, putting it in the middle hole, you'll see that it holds the pinion gear on like that, should you want to put it in the car like that. Or you can put it in a pocket, and you can stick it on like that. The BSRT, same way. Pops in the pocket, stick it on the car. So that's that. The next two gears we've got a Viper Scale Racing here in black, and in this particular gear right here, this is a BSRT 7-tooth. So let's put that in the bottom hole here. On the back, we'll see it holds on there just fine. Let's see what the Scale Auto gear does. A little tighter, but still it holds on. Pop it in the pocket. We can get it in there. There you go. Holds it just fine to get it up into the car. And then the Viper gear, the same way. Alright, and we may get some examples here on the next little segment to show you kind of how this works, putting them in the car. The 1mm shaft that we sell for Mega G Plus cars and Lifelike T cars, that runs real good in the top hole. Alright, our HCS 7-tooth pinion, it runs in the back hole just fine. In fact, a really nice snug fit. It's a little tight going in the top hole, so this particular gear, if this is the one you like to use, then you just use it like that and it holds on. There is another 7-tooth pinion that I sell that's based off of a Lifelike gear. It doesn't have much nipple at all, but it'll fit in the top hole just fine. The line of RPM gears with this tool is a little problematic. Their nipple, we want to check that. Their nipple shows about 063 and a half. So we have the top hole at 063, and it does fit very tight. So you could use that hole to hold the gear while you get it into the car. I think the diameter of his gears are just a touch large, so it really doesn't fit in any of our standard holes. Now, the thing with this tool, guys, is they're not going to be that expensive. If you want to modify this thing to suit your applications, if you have one style of gear that you like to use and some of these holes are just a touch small, you know, you could probably get some type of reamer or something like that and just open them up a little bit. This is aluminum, and I'm sure it would respond to a reamer quite well. I haven't personally done that, but in other tools in the past I have done it, not particularly on this one. So you could modify this to suit your applications. Alright, so let's see how this thing works in practical application. Alright, take a Super 7 car. This one's all together, ready to rock. But let's pretend that the pinion gear's bad. Come into the bottom, use the fork, kind of get in there and pry that thing off. Okay? And to put a new one on, just pop the gear in like such. That'll hold it up to while you get it into the chassis and push it home. And depending on gears or whatever, the way they fit on pinion shafts, I mean there's all kinds of various combinations that once you get the back axle in the car, you may have to bring the pinion out a little bit more, so you can just kind of get in there with your pry tool and kind of fine tune that a little bit. This is what this is for. Common car that this is probably going to be used on a lot, Mega G Plus. And by the way, cheap body that just cracked in half. For all the money they pay, this particular car has just been hugely problematic. Just terrible. Absolutely terrible. So when I got this particular Mega G here a while back, the stock pinion gear was just, they didn't mold the hole correctly. So it's put on very, very tight. It's got a very long shank, so the forks just about don't do any good. You could try, but I had to kind of get in with like an X-Acto knife and kind of start it to get it off, and then we used our standard 7-tooth pinion for Mega G Plus. Let's just pop that in a little holder like such. Have our car, get it up on in there. Wunderbar. Okay, let's put our axle in, see if it needs any adjustment at all. Happens to work pretty good. We got it just in about the right spot. Alright, so that's kind of the basics of pinion tools. You got any questions once you get it in your hands and use it, you can certainly call me. That's generally the easiest thing to do. You can write an email or something like that, but technical things like this is kind of better if you call, because we can really get some work done then if we have a phone conversation. Alright, well, next up we'll talk about the tire sizing tool. Alright, so let's get into our tire sizing tool. First off, kind of preface this, there have been a number of these gauges made by a number of people over the years. There's no telling, who designed those tools, who made the tools, how many tools was in any one production run. When they went back for another production run, did the same company make them? Did somebody else make them? My point is like with anything in life, especially anything that's machined or manufactured, there is a certain amount of variance. We're not making parts for the space shuttle, so there will be very, very minor tolerances. Okay, so on things like this, it might be plus or minus 0.02 of an inch. Okay, to hold tighter than that, the price of the part might double, triple, quadruple, who knows what. Or the company that quoted the parts, if you wanted something tighter than that, let's say 1/1000th or 0.5 they may not be able to quote the part, and you'd have to go someplace else to find the work that can be, to NASA precision. But what you need to understand about this tire gauge, or any tire gauge, it is somewhat relative to your situation. Okay, one of the very first things one of the very first tools I ever bought when I first got into this hobby was actually a Wizard tire sizing gauge. I don't think they make it anymore. It was a fairly hefty little thing made out of stainless steel. and then, you know, pullers, presses, things like that, just the basics. But a tire sizing gauge is probably one of the most important tools you will need in order to figure out how to fine-tune your car, because, you know, our cars, our little race cars, aren't subject exactly to gravity and wind resistance like a full-size car is. So to get the performance we need, we got to have artificial gravity and or artificial downforce, and that comes through magnets. Tire size is really, really important, probably more important here for fine performance than maybe a pancake motor car. I know I may get some haters on that from guys that run Frey, which I know that tire size is exceedingly important in that class, but for more of the play car applications, not so much. So anyway, we have a gauge that is sort of divided into two primary things. One's labeled front tires, one labels back tires. There may be some overlap in your applications. I mean, you may get, you know, rear silicone sponge tires for freight cars. You'll be measuring down here. So this is a general recommendation for, you know, inline cars, Tyco 440s, you know, Lifelike, things like that. And then the rear tire size, very, very similar, starting at 416 and then going up to a large of 500. And we'll get some examples here in just a second. Alright, so we're going to start off with a Viper Scale Racing rear axle set that has a 250 double flanged hub on it. So we're going to put on one of their blue PST tires, and the label says that it should be around 432 on a 250 rear hub. So if we look for our 432, which is right there, we'll put that in, and there's just a touch of friction. Okay, the way I use a tire gauge, to me that's about right. You don't want it to fall through like that, because I don't consider the next size up like that to be the tire size, because the tire is going to be crushed a little bit, you know, from gravity. Now the 430, you got to really work to kind of push it through, so I don't consider it that size. So I look at the gauge as to if I've got to really work, it's not that size, and if I don't have to work, it's not that size. So something where it just kind of gives you some little bit of resistance going in, that's going to be the size. Now, when I was racing heavily, oh gosh, it's been a dozen years or so ago, when we were running ceramic super stock that required silicone sponge tires, you really had to understand what you got. You could not rely on the label that the tires came in as to what the true effective size was. So when I would get in a bunch of tires, the first thing I'd do is I'd open every package and I would check on my gauge, which at that time was a Wizard tire gauge, and most of the time those silicone sponge tires would be something different than what the label was. And that comes from probably whoever made them. The way they measure tires is different than the way I measure tires. There was one guy that all of his tires were consistent in, let's just say you got a 428. If you checked it, it would just, I mean, it would almost fall through a 428, and then I would check it and I'd get some little bit of resistance on a 426. Well, I'd put it in my little box under the 426. That's just the way my brain thought. So you develop something that works for you. The tool will help you get there. So figure out something in your own application that's repeatable, okay, that makes sense to you, and stick with it. There isn't any written rules much or anything like that on how to use one of these things. It's up to each individual to figure out how they want to use the gauge. I mean, some guys, they may think, okay, I don't have enough resistance on 432, even though that's the label size, but you know, I think it's more of a 430, so I'm going to label them, you know, 430 in my box. All right, so another size, let's go down to probably, let's see, let me check my little box here, label size 424, which should be this hole right here. And that one, this particular tire, that gives me a little bit of resistance that I don't like. It's more, kind of more 426. So this particular tire is that. The next tire might be cooperative because, you know, here again we're dealing with material that has a shrink or a swell rate. We don't know what that is, but we'll go to the final one, which is a 416 label, and we will check that. And that here again, this is more what I would call 416, where it just needs a little bit of pressure and it sticks there. 18, yeah, but it's very, very light. And then obviously 420, it just falls through. So here again, it's kind of a relative scale. Go with what works for you. All right, let's look at some bigger tires. All right. So we have a Mega G tire here. Let me see here. That'll fit on. Let me go grab that Mega G car here real quick. All right. So factory rear axle. What size are these tires? Probably pretty big. Falls through a 470. Falls through a 468. 466. Let's go down to 62. Maybe 460. It's going to be about a 460, 462, somewhere in that area. It's really a big tire. All right, so the label size on this tire is 454. Now, I didn't create that label size. That's just what the manufacturer that I get them from claims them to be. Okay, but look at there, 454. Just, you know, not real tight, not real loose. 56 is kind of loose. See that right there? So the label size with this gauge and the factory hub and this particular tire gives me 454. You could maybe have a gauge made by Scale Auto or an old Wizard gauge that might measure it one size up or down or right on. Don't know. It's just one of those things that you have to check. So we got very fortunate on that particular example that it's right on the money. Alright, so let's go to a Lifelike. Alright, we've got a 455. Here again we'll use the Mega G rear hub, and just for giggles, it's a 275, which is probably a little touch smaller than what Lifelike hubs might be, but we'll see if it's a 455. And on a Lifelike, excuse me, on a Mega G Plus rear hub, it's more like a 448. Alright, so let's go find an actual Lifelike rear hub. Alright, back at it. Genuine factory Lifelike rear axle set out of an M car. Now, it seems, if I recall right, there may have been a couple of different sizes that they did over time. This particular hub is a 285. So with our label size of 455, I would say that that's indeed correct. On the Lifelike factory hub, kind of tight on a 454, a little loose on a 456, so this label size is correct. So far so good. There's another one here, the label size of 450. Let's see if that's indeed to specification. Yep, just about right on it. Alright, let's get some Tyco rims. Alright, typical Tyco factory 440 rear axle set. Label size on this tire here is 454. Let's see how we do. Just a touch loose. just a touch loose. I'd say it's more 452-ish, but definitely not 456. So this particular tire, it's close, but it's more of a 452 size than a 456. Alright, the larger size that I carry is labeled 472. So let's check that out. I'm going to get on up here. Let's try 470. It's kind of loose on 470. Obviously very loose on 472. So these bigger tires really probably more of a 466 really in that, but I'm going with the current label size of 472 on that. I'm unsure how the guy that makes these determined that. That's the problem. You don't know what type of rim that he checked them on. So this is where this thing could be help, you know, when you're trying to figure out maybe one tire size down or up to get your car to handle. You know, if the car feels kind of loose, check the tire size. If it's big and you put on a smaller tire and you get where you need to be, good, you learn something. Alright, let's take two cars. This is a Viper Production V-Spec. Alright, and I think, as I recall, I put 432s on the back. So let's pop that back axle out. Could be 28s, we'll see. Well, it's it looks like it's probably about 28s. One tire, this is kind of crazy how these tires work. One tire to me is a little bit loose up here at the 32, but you switch the axle around and then the other tire is just a touch more. So it just proves to you that, you know, the tire size can be just a little bit of an art form. So the back tires are probably correct. I probably did pull them out of the 432 cubby. I think the front tires that I use on these are somewhere around 340, the O-rings thereabouts. So let's find our 340 hole, and we can just check that and like, yep, it's about right. It doesn't really. Now, let me pull this axle off this. I'm not happy with this. Let's try it again. Yeah, there we go. 340. Okay. 345 doesn't go through. .330. .345, right? Okay, and then I had another little project car here that I put together, and I put some albinos on it, and I probably dropped them down. So let's see what size I put on there. Probably 16s, yeah, or 20s. Right there, sticks in a 418, floats through on a 20, thereabouts. See, one tire 420, the other tire just a touch looser. So you could use this once you get your tires mounted to, you know, fine-tune tires. If you had like 10 pairs of tires to kind of go through and find the ones that are really closely matched, it may help you do that. So, and then okay, another example here. Let's look at Super 7 real quick. These should be 454s, I think. These hubs, these more like 448s. That's what I call them, right? Tight on a 46, right about on a 48, floating on a 50. And then the front tires, they're going to be big. So it's going to be somewhere between a 90 and an 85. on that tire. This particular tire, here again, there's some variance on the tire size. It falls through a 385, but the 380, it's tight. The other tire is tight on a 385, falls through on a 90. So if we pull the tire off and reseat it, kind of massage it down, let's see if that changes anything. A little bit. A little bit. So a lot of times, you roll that tire in because it might be bunched up. Get it kind of rolled down a little bit. Those are things that you can do. So it floats through the 85. This other one's a little looser. Here again, if you're really trying to fine tune, you can use this to weed through parts and get them where they need to be. It's a physical impossibility to get things like these tires, every one of them made exactly the same. These silicon tires, I guess they're made in a large plate that have different cavities, and the material is spread over that, and so you may have some small manufacturing variances from cavity to cavity that could account for some of this. Don't know. It's impossible for any of us to know precisely exactly how all that works, but it's not one cavity the guy's cranking out 1,000 tires a day out of. I mean, he's got these big sheets or whatever. When he screets out his silicon, he's going to make a lot of tires. But anyway, I'm happy with this thing. Looks like it's done pretty good, and we'll get those listed. And if you have, here again, any questions with this stuff, give me a call.